Hi, Frag. So when we get going away, just put everybody on mute and video off after intros. We can record now. Welcome everybody. Just wait a couple of minutes, a few seconds, just to wait for everyone to join the conference, the webinar. Sorry.
Just try to put my headphones on. Might hear better.
Right, we'll get underway. Welcome everybody. I'm Philip Aldridge, Executive Director at HASN. So welcome to this webinar on local exhaust ventilation. So introduce the people. So we've got Pip Gibson next to me in Wellington office from WorkSafe, Al from WorkSafe, and down in Oxford, and Farag. So welcome everybody. So just in terms of logistics, most of you have done this sort of thing before, but you'll be on video off and muted. But for our session, you can use the chat function or Q&A to ask questions. So basically, we'll run through a bit of introductions. Al and Pip will do a bit of an overview for the next 30 minutes, the presentation, and then there'll be plenty of time for Q&A. So the Q&A button is right in the sort of bottom left of your screen, so put things in there. So we are recording the session, and we'll send out the recording and the presentation next later this afternoon once we do it. So thanks a lot. And thanks. Hi, Vanessa. Righty-ho. So Pip, talking about Pip, who's next to me. She's a principal specialist at work-related health at WorkSafe and program lead for carcinogens and airborne risks. She specialises in health risk management, particularly health assessment. She is certified by the American Board of Industrial Hygiene, as well as certified as an occupational hygienist by the Australian Institute of Occupational Hygienists. She's a board member of International Occupational Hygiene Association as a fellow of NZOHS. She's also an inspector, WorkSafe inspector.
Yeah.
Didn't know that. Al, on the other end of the call. So Al is a technical specialist in work-related health at WorkSafe, background health risk assessment and personal protective equipment. Al is a member of New Zealand Occupational Hygiene Society and Australian Institute of Hygienists. He's also an inspector. So over to you, Al, to kick things off. Or maybe put up the slide and then Pip, you starting off, aren't you?
Yeah, I'm starting off. Yeah.
Okay. Al, we want to start sharing the screen.
Yep, should be up now.
Hello, Vanessa. Right. Are you shoving over?
I'll shove over.
There's no knee room under here.
Isn't there? Okay. You can go.
Hi, so welcome everybody. Thanks for coming along. The reason that we focused on good practice in next slide, please, Al. Is Al controlling it or am I controlling it?
Al's controlling
it. The reason that we're focusing on good extraction ventilation is that the majority of work-related health issues relate to exposure, airborne exposure. If we look at the work-related health deaths, I'm sure you've seen these stats before, but it's estimated that around 750 to 900 people die a year from work-related disease or illness, and around 50% of those are cancers and 30% chronic obstructive pulmonary disease. So a lot of the exposures causing those fatalities are airborne exposures. In fact, the majority are. Oh, yes. Next, please, Al. So the upshot is that a worker is 10 times more likely to die from a work-related illness or disease than they are to die from an incident or an accident at work. Next slide. And in addition to the fatalities, there are an estimated 5,000 to 6,000 hospitalizations each year due to work-related ill health. And again, the majority of those illnesses are related to things that workers have been inhaling in the workplace. If we look at the burden of work-related injury, ill health, thank you, we're just changing my screen so I can see better. So this circle represents the overall burden of health and safety harms and including deaths and injuries for the whole of New Zealand, for whole of health and safety. And if you look at the little yellow slice there, the yellow slice represents the contribution from accidents and injuries at work. The rest of it, so the remaining huge chunk of that, is work-related illnesses and diseases. That's estimated that every year there's an estimated 50,000 healthy years of life lost in New Zealand per year from health and safety harms. And what that means is that, for example, if a worker dies at work at the age of 30, the 40 or so years of healthy life that would be estimated they would have left get added into that total. And the total actually is around 50,000 healthy years of life lost because of health and safety injuries and illnesses. It's really massive. And that costs the economy around $2 billion a year. And so, like I say, only 11% of that is injuries and accidents at work, which is probably the thing that's forefront in people's minds around workplaces, but that's by far the majority is work-related health. And if we look at the orange and the blue slice there, that represents cancers and respiratory disease. So that makes up around 30% of that $2 billion a year, or 50,000 healthy years of life lost. Next slide, please, Al. Thank you. So for the reason this is, so for this reason that carcinogens and airborne risks contribute so significantly to our health and safety disease burden, WorkSafe we've got a really big focus on that area for the next few years. And what that means is that we're going to be doing a whole bunch of activities within WorkSafe, including such as targeted assessments from our inspectors, working on our guidance and information available for PCBUs to manage risk, plus doing a whole lot of work, including working with HAZANs and other organisations outside of WorkSafe, so that we can make really significant change to the overall health and safety system, because we really need to make a really big impact on reducing that contribution to the harms caused by carcinogens and airborne risks. So you'll be seeing quite a lot of media and information and conference presentations and interactions focusing particularly on the space for the next couple of years. Next one, thanks. So in terms of extraction ventilation and why I've just given you all that background for this, obviously extraction ventilation is there to manage airborne risk, airborne substances hazardous to health. And the key, there are a number of parts of the Act where extraction ventilation is essentially brought into the Act, but the key ones are under the General Risk and Workplace Management Regulations. The first of those being Regulation 6, which is the hierarchy of controls, which of course says that if you that the PCBU must eliminate risk so far as reasonably practicable, but only if it's not reasonably practicable, then can you move on to minimising risk. And the first thing that must be considered in minimisation is substitution and or isolation and or engineering controls. So in a workplace that's minimising, they might have a combination of those things or one or other of those things. And extraction ventilation sits under Part C, which is the engineering controls. And only then, once those options have been considered and determined either whether they're not reasonably practicable, can you then move down to administration controls and then very lastly PPE, or a PCBU might have a combination of controls including extraction ventilation plus in addition have, because there is residual risk or remaining risk, they may then also implement administration controls and perhaps PPE. Next one, thanks. And the other key regulation in regards to extraction ventilation is Regulation 7 of GRWM, which is the duty to maintain effective control measures. So obviously there's no point having a ventilation system that is not actually doing what it's intended to do. It's not uncommon when you ask workers or PCBUs how they are sure that their ventilation system is working, for them to reply that we know it's working because when we turn it on, it makes a noise. Like that is literally sometimes their only measure of effectiveness. But the law is very, very clear that the ventilation system has to be fit for purpose, has to be suitable for the nature and duration of the work and installed correctly, set up correctly and used correctly. So all of these things are really, really important. And Al will talk a little bit more detail about those. So the design in terms of the hood shape, location, etc., has to be fit for purpose, as in has to be suitable for that particular workplace, those particular exposures. And the PCBU has a clear legal duty to be able to show and to demonstrate to an inspector, for example, that the system is effective at doing what it's meant to do. And in addition, there are other duties. So under the Act itself, there are duties around the design of plant and equipment, around plant, And there's also duties around the import and supply of plant, and there are things like performance tests and calculations that must be provided to, in terms of using that plant. So extraction ventilation that is designed that for a PCBU, there is required to be some documentation around how that piece of equipment has been tested, has been designed, and has been shown to be effective. Next one. So the very basics of managing airborne risks is the most effective way in terms of managing risk is to focus the efforts and energies on the source of the exposure. And for example, extraction ventilation, that's focused on minimizing the amount of escape of the contaminants into the air. If that's not reasonably practicable, then the next best thing to do is to look at the pathway between the source and the worker, such as using distance as a control, or perhaps some barriers, for example, or perhaps even general dilution ventilation. And then only lastly, just like the hierarchy of controls, should you be putting your efforts into managing risk for a worker by using protective equipment? Now, in reality, there might be a combination of all of those phases necessary for managing airborne exposures, but where you get your most bang for the buck, and the very first thing that should be done is to focus on managing control at the source. Over to you, Al.
Thanks, Pip. So we're just going to move on to talking more about LEV systems. So LEV, or local exhaust ventilation, usually consists of a number of things: a capture system, which could be a hood or an inlet that the particulates or the contaminants will actually go through, the ducting which the air moves through, something to make the air, such as a fan, an air mover, a system to clean the air and removes the contaminants from the air, and then finally the discharge. So that's the basics of what pretty much every LEV system is made up of. From that, we get two types of LEV that we commonly see. The first one is enclosing hoods. They're a closed-in system with a lot less chance of contaminants escaping from it. So you might see these in like a small abrasive blasting cabinet. We see a lot of these enclosing hoods in the pharmaceutical industry. You'll also see it where you actually do spray painting with gloves and things like that, where it's all contained within. So there's a lot less chance of exposure with enclosing hoods. However, the majority of the systems that we do see are what we call capture hoods. As you can see in the picture there, you have someone who's welding. They have a big, looks like cone-shaped funnel that sucks the air in. That's more what we see everywhere out in industry. The problem with that is, because it's not enclosed, it relies on being set up correctly to work. So if it's not set up in the right place, then you're going to end up with problems. So what we want to do is introduce you to this terminology around zones. So capture hoods will have a limited range of effectiveness, what we call the capture zone. So in the pictures above that are from the HSE UK is a yellow circle that extends out of the capture hood there, and that's called our capture zone. The area that we do our work is shown there in the green zone, and that's called our working zone. So what we ideally want to do is we want our capture zone and our working zone to overlap, because the working zone is where all the contaminants are. So whether it's a gas or a vapor or sand or stone or welding fume, we want that overlap. But what happens is, as soon as you move the working zone away from the capture zone, you end up with that overlap not being so much, and it gives a chance for contaminants to escape. So the LEV doesn't become as effective as it should be. And it will decrease dramatically the further it gets away from that capture zone. So probably if you have an LEV system, you might want to go after this presentation, if you're working on a site or something like that, just go have a look and see how well your capture zones are overlapping with your working zones. A little bit of light actually allows you to see this. You can see the background lighting there. If you look into a light, you'll be able to see the contaminants making their way away from that capture zone. So it's a challenge for you to go back and have a look and seeing what changes you can make this afternoon to make it a little bit more effective. selecting LEV for your work is one of the critical points with this whole process. Poor selection leads on to multiple issues, including further risks. An accumulation of dust or vapors in a duct may become a fire risk. You can have the ductwork catching on fire, or if you go and place a loud fan in the wrong place, you'll have increased noise exposures for your workers. So what you need to do is actually select what's going to work for your workplace. If the system isn't selected correctly, what will happen is you won't actually remove all the contaminants that you were designing it for. One of the crucial things is that LEV is a specialized field that requires experienced and competent specialists to deliver. It's not something that a skilled person can turn around and make a system from scratch if they don't have that experience. They need that experience to know what happens. And there's potentially one of the things is there's a lot of other industries out there like heating and ventilation and air conditioning system people that think that, oh, it's all very similar. It's all ductwork. It's all, you know, capturing things and moving air. It's all about fans. But you actually do need that specialist people to actually put a system together. If you're not familiar with designing these, then you could end up with a system that just doesn't work. The other thing with these systems is if they don't work or they're not user-friendly or, you know, the workers don't like them, then they become a waste of time and money. The workers will put them aside and discard them. I don't know how many places I've been to as an occupational hygienist and found portable LEV systems sitting in a corner, not being used, or even fixed systems not being used, the capture hoods hung up on the wall because they don't work with the job that the person is doing. They don't actually fit in with the way that that person works. So it's really important that when you start off on this process of putting in place LEV, you get the right people involved at the start. And that includes the workers. You have a duty to actually talk to your workers. You need to actually include them in this when putting the controls in place, because without their buy-in to this, they're not going to use it as it needs to be used. So when we first come to it, we need to establish what the system will need to do. Does it need to remove welding fume? Does it need to remove wood dust? Does it need to remove acid mist? This is really important questions to ask because it's going to determine what materials you use, what components you're going to use, what the design is going to look like, and importantly, the amount of air the fan needs to move. If you don't understand that contaminant that you're trying to remove, you're probably not going to put a system in place that's going to be effective in removing that. For example, wood dust takes more air movement than fume moving in a duct. So you need to also then go and look at what the tasks are that you're going to be done in that capture zone. So again, we're trying to match that capture zone and the working zone. We've got to make sure that we're not designing a capture hood that's way too small for what we need to, for the working zone that we need to capture. You also need to look at how do the contaminants move. So an example might be, you might be welding and the welding fume is drifting up. It's only ever drifting up. If that's the case, you want to have your capture zone potentially above where the welding's taking place. However, if you're trying to capture on something like a saw, cutting wood, you'd want the capture zone to be where the wood is ejecting itself as it flies out of the saw blade. So you want to make sure that it's going in the right place. By having that placed in the right place, especially with things that are being ejected, it means you need a lot less air than trying to, if you can imagine trying to suck sawdust out of an air in the opposite direction that the sawdust is actually moving. You need to know how many capture hoods are you going to run off the system. How much are you going to put onto this? Will they all be operating at once or one at a time? This is going to be significant in determining how much air you need moved. Getting this right in the beginning saves a significant amount of cost in the long run. If you don't get this right now, you'll be forever chasing your tail, and alterations are by far more expensive than getting it right at this stage. One of the critical parts, and this is something we don't see a lot of happening, and it's unfortunate because there's a lot of people that go out there and they'll buy a system and think that this has solved all their problems. The solution to make sure that it does, especially before you pay your bills, is to commission the system. Commissioning is essential to LEV. Without commissioning, we can't be sure that it's doing the job that you need it to do. So it may not remove those contaminants that you initially sourced it to do. And you don't know what the correct setup for the system is, meaning we can't check it later or see that it's still performing. So by having your initial measurements of how much air is moving in that capture zone or in your ducts, you can then see over time whether it's decreased. And you can start troubleshooting to work out, do I have a problem with my fan, or have I got blockages in the ducts, or have I got holes in the ducts? By having that commissioning data, you can start to put that together to be able to go, okay, this is indicating we've got a problem, so we need to have it. If you have LEV, it'd be really important to go back and ask what commissioning has occurred when it was installed. So it's not too late to actually go back and commission the system and work that all out if it hasn't been done. Really critical parts is the supplier should provide you those things listed on the screen. So training for the workers. Without that training, the workers are just assuming that's how it works. And it cannot, and sometimes it's not always as straightforward as what they seem. The common one we see is people just place the capture hood above their work and think it's capturing because the fume is rising up, but there's actually working out that capture zone and the distance that it needs to be put in place. Should also have maintenance and replacement schedules all put in place. You have a user manual and logbook, a list of consumable parts, so that you might want to have parts on hand that are easy to replace and user replaceable, so the system isn't down for a matter of time. Because what then happens is if a system like LEV is down, people start going, well, I've got to do this job. I'll jump in and I'll just do it quickly, but then they're getting exposed to that time. So when you're looking at effective management of your LEV, you got to look at it like everything we do in work-related health. We try to put a system in place. One of the cornerstones of that system is making sure that you've got a responsible person that is responsible for that system. Basically, the buck stops with that person if it's not working. What that means is that person's then going to take responsibility for going and doing checks on the system, making sure the right consumer parts are being used, making sure people are using it effectively. Without that, you're just relying to the everyday, oh, the worker knows how to use it. They're going to use it how they do, and no one really knows. Got to make sure the training is there. We can't reinforce that. Without the training, the worker will just make assumptions and they'll go ahead and use it how they think it should be used. There'll be times when you'll have to replace parts. These parts wear out, fan bearings, other non-moving parts, hoods and ducts, especially if you've got a hot process, like we were talking with an acid mist, you might get degradation of the products around the hood. And all of a sudden, even a small cut in the hood may change how that actually, the capture zone that it actually has. And what you're used to isn't as effective as it used to be. You've got to have a system so that people can report the defects, can report problems with it. Quite often the workers are the best people to determine when something's changed and not changed for the good. So if there's something wrong with it, it doesn't seem to be sucking as much as it used to, or you know, I don't get it capturing over this side of the workbench. These are the things that you need a process in place so that you find out about them. You should be looking at regular servicing of these. These systems, you're talking about contaminants that will wear away materials. You know, they'll wear away on plastic, they'll wear away on metal, and you end up with holes in joints, and you end up with holes in the ducting. You may end up with fan blades that are no longer intact. All these things need to be regularly looked at and serviced, and that's where you get someone in who knows how the system works and can put their eye over it and actually do that. We also need to keep a record of all the completed checks and maintenance, and that should be just a done deal thing that you do. And that's primarily so when you need to look at it later on, you can go, oh, geez, we haven't actually repaired that fan in 2 to 3 years. Maybe it's about time we had a greater look at it. It's like servicing your car. You don't get everything done to your car on one service, but you have the service history that then directs your mechanic to then focus on the things that may be going wrong next or are going to go wrong in that thousands of kilometres. So these are the kind of principles that we'd be applying to it. We can't highlight the importance of regular maintenance and checks. Even though you might have people reporting things going wrong, it may not be obvious that something major is going wrong. So what we require, the regulations require you to maintain and review effective control measures, and that is part of your regular maintenance and checks. One of the things that happens, and this is legislated in other jurisdictions across the world, is that your LEV has to be tested on a regular basis. So for example, in the United Kingdom, every 14 months, you'll need your LEV system checked. So this is important that you'll be able to find out those things that are going to go wrong or that it's not working effectively and that you need to fix it. If you need to get an assessment done, you should be consulting an occupational hygienist or an industrial ventilation engineer, a specialist engineer, to assist you with that testing. They're the people that you'll go to first. To check that your control measures continue to be effective, this is where your exposure monitoring and health monitoring will come in. This is to determine whether you are actually keeping those exposures under control. So what might happen if you have an exposure monitoring come in, it might actually show you that even though the LEV is there and it seems like it's working, as Pip said before, that it's making the noise, it may not be removing those contaminants and still exposing your workers. So you do need that regular exposure monitoring going through and over the long term. Critical point is, the last thing I'm going to hit is making changes to your LEV. It's really important that you don't decide to go along and add another capture hood or add a bigger fan or change your system in the way that you're doing it. You may change the filters. These can all affect how your system works. You need to engage with a specialist to make sure that what you're doing in those changes isn't going to affect it. So if you think about an air conditioning system in an office building that is balanced, it is the exact same thing that we're trying to do here. As soon as you disrupt air by putting in, taking extra air out to another capture hood, you'll notice a decrease in the effectiveness of other places. So it's really important that when you disrupt this balance, when you make any changes, that you get the system reassessed and make sure that it's still capable of controlling the exposures. We've got, just if you are looking for more information, WorkSafe has just last year, we updated our guidance for local exhaust ventilation. So jump onto our website and search for local exhaust ventilation. And we also have updated new guidance in there for the people that supply LEV. So what their upstream duties are. So what they need to do to make sure that when they sell or import or distribute an LEV systems and equipment, that they're meeting their upstream duties. Also there, to contact an occupational hygiene practitioner, go to your HAZANS register. All the occupational hygienists on the HAZANS register have been through an assessment by the NZOHS to basically look at their competence and their skill and their experience to make sure that they're capable of doing the work that they do. That's it for us. We'll hand it back over to Phil and we'll jump into, I think, the Q&A.
Yeah, thanks, Al and Pip. That's great. So any questions you have, fire them into the Q&A function down in the bottom of your screen. Just one question before we kick off, Al, maybe you can answer. You mentioned a responsible person looking after overseeing the LEV. What sort of skills, experience would you expect them to see?
Philip, you're going to see a variety of skills and experiences depending on the size of business. So, you know, when you're talking a small business with, you know, 2 or 3 workers, you're not going to be looking for a whole heap of skills or experience. They're just going to be responsible for making sure that their workers are using the system properly and that it's maintained and effective. You might go to bigger PCBs and larger things where you may have someone like Farai who's on the panel, who may be responsible, a ventilation engineer that's there. So it could be all kinds of people. But what you need to do if you do have that responsibility is understand what you're doing in terms of making sure the LEV is effective. So being familiar with that guidance that we've got on our website.
Okay, there's one question from Greg. On the chat function, can dust be discharged to the atmosphere or should they be captured internally?
I'll go for that, Pip.
Sure. Yep.
Yeah. So this is all going to be dependent on where you're located. So one side that we didn't talk about is all the other legislation that you need to satisfy in terms of environmental. So in terms of your discharge, you need to probably look at the consents that you have with your local council, your regional council, and make sure that you're not, breaking any rules there with your local councils on discharge.
Great. Another question from Damien. Thanks that. What recommendations for heavy fabrication where workpieces are up to 25 meters long, 5 meters wide? What would you make? Welding, grinding dust. So basically, heavy fabrication plant, presumably it's steel or something like that, aluminium maybe. What sort of recommendations would you suggest? Probably hard to answer, isn't it?
Yeah, that's quite hard one to answer. I mean, I think you definitely, as per the hierarchy of control, you'd have to look into engineering controls before going straight to PPE. It all comes down to what's reasonably practicable. I mean, and it may not be reasonably practicable to put in local exhaust ventilation, but certainly you would have to consider that and actually properly consider it, not just go, oh no, it's too expensive, therefore we're not going to do it, because the cost factor around reasonably practicable comes after the duty to manage risk in regards to have regard to the risk, the level of risk, the level of harm that could occur, and how easy it is to, and what methods are available to manage that risk. So so there may not be a ventilation option is actually a possibility, but you should be considering that before going straight to PPE.
I was going to say, you might be interested that we've just released some new guidance on welding. So check that out. That it is, as Pip said, it's not just straightforward. You need to have it. It depends on the whole situation. And you should also look at what could potentially make the exposure worse. So if you're doing that inside and with no natural ventilation, then it's worse than if you're outside and had other ventilation. So you need to consider what will make it worse as well.
Good point. I'd like to ask a question of Farag now. He's on the call. So I understand you're a consultant. So perhaps outline what sort of work that you do and what type of things you see in the market or in industry.
Okay. Thank you, Dave. First of all, I'll just answer the question that I'm just seeing in front of me, which is talking about there was a mention of test reports being provided by suppliers for LEV equipment, etc. Any suggestion where we can find this detail or what exactly I should ask for, as we'd like to be able to consider these best results when purchasing? Well, first of all, when you are looking at an LEV system, you need to have an idea of the size or the quantity of air that you require. That's one thing. You need to know the pressures that you are expecting in your system, because those two will provide you with the duty point of your fans. So when you go to the manufacturer, you are asking the manufacturer to say, this is the quantity that I expect. This is the pressures that I expect from from the fan that I want. Can you provide me with a fan that meets this criteria? So the most important things are the pressure and the quantity that you want out of that fan. Of course, once this system is being designed, the ductwork that you install has a huge bearing on how your pressure, how the pressure of your fan actually acts. In saying this, what I'm saying is sometimes how you install your ductwork can increase or reduce the pressure of your system. So so it's very important that you get someone who is able to design the system to minimize the amount of pressure for your system. You will find that in most LEV systems that are industrial based, the type of fans that you are going to have are centrifugal fans, because these are high pressure and high volume fans, whereas an auxiliary fan tends to be low pressure but high volume. And also it has the advantage that for any systems that are extracting contaminants that are toxic or corrosive, an auxiliary fan is not suitable because those corrosive fumes go through the motor and your blades. So it will tend to corrode your motor system quickly. Whereas a centrifugal system, the motor is normally out of your fan blade enclosure. So what you are only dealing with is fumes that are being exhausted. Even if they are corrosive, they are only going to impact on the blades, but not on the motor. So with time, this will involve you having to continuously monitor, is what I was saying, that you need to constantly monitor your system, because with time, that corrosion that is occurring on your blades will start to eat away on your blades, and it will affect the pressure of your system and the quantity that you get in the end. So that's just a brief monitoring. So what do I do? Well, basically, I am a ventilation officer and a ventilation engineer. I qualified at the University of New South Wales in a postgraduate diploma for mine ventilation systems. So my job is to, first of all, design ventilation systems and also recommend the correct type of fans for these systems that we have designed. So we either use forced ventilation systems, which is pushing air towards a workplace, or exhaust ventilation systems, which is extracting the air away from that system. My job also involves monitoring these ventilation systems, and we use various tools like vane anemometers to measure air quantity. We also have thermal anemometers, which are very accurate systems to monitor these. And we also have pressure manometers to measure these.
Right, thanks for that.
Yeah,
thanks, Jack.
thank you.
Thank you for that. Very useful. Pass across to Pip now. So there's a, I'm trying to read it out. You can read it out.
This is a question from Noddy. Hi, Peter Knock. There are now on-torch welding fume extractors available, but they appear to be difficult to get welders to adopt them over hood types. Any thoughts or strategies to encourage increased uptake? Well, good question. My first thought is the manufacturers. I wonder if they've done any looking into why people choose not to use them, or why they choose other methods. I mean, I don't know whether it might be an ergonomic thing, or just people are used to one thing and need a bit of encouragement to change, or need a lot of encouragement to change. I don't have any strategies or thoughts on that at the moment, because I think that really comes down to really understanding why people are not inclined to use them. And that's probably where the strategy around getting people to adopt them would come out of. Any thoughts yourself, Al, on that?
I think you hit the nail on the head there, Pip. At the end is, if the worker doesn't like it, they're not going to adopt to it. So involving the worker at the very beginning, rather than trying to turn around and go, hey, here's this, use this. So maybe even getting the worker to come up with the idea of, how about we try these out? My experience with them is they're heavy. So when you start working with, long term, again, it's the ergonomics of it that become the issue. Workers just get tired with them and things like that. So yeah, overcoming those with the workers is the best sort of strategy that you can come up with. yeah, go to the manufacturer, see what they have to try and get them to be adopted.
Cool. Thanks for that, Alan. If you've got any more questions, please fire them in.
Oh, one more thing before I forget, there is a short course, 4 days long, on extraction ventilation coming up in October. It's run via the New Zealand Occupational Hygiene Society, and it's a course it's an IP course that's part of the British Occupational Hygiene Society series of courses. It's normally a face-to-face course, but they've adapted it to run online. So that's online in October for Monday to Thursday. I think it's the 16th or 18th of October it starts, but you can find that on the New Zealand Occupational Hygiene website if you want to register for that.
Thanks for that. So there's not too many questions. I finished a bit early, so perhaps we'll just have concluding marks from Al and Pip. So Al, any sort of thoughts or really the real key things that you think are important around the space?
I think we've got to put the number 8 wire mentality behind us when it comes to LEV. That we can't just bend some metal and make a system. We actually need to put some thought into how we're doing it, and also make sure that it's effective at the end. There's nothing worse than a control that doesn't work.
Yeah, absolutely, 100%. And so there's legal duties around it. That's the other thing to mention, them sort of the harder word side of it. Certainly we failures around the management and assessment and even determining whether or not LEV is effective have formed part of prosecutions where PCBUs are found guilty around not managing to around failing to manage risk. So not saying that that's what we're all about at WorkSafe as prosecution, but there are legal duties and we expect those to be complied with, because that's how you know that you're managing risks sufficiently.
Thanks, Al, Pip and Frag. So certainly interesting to hear how it can work and make sure bring into sort of the workers into the conversation, make sure actually the new solutions are designed for them in mind, not just the extraction, but actually the weight and usability. And interesting from him, from Pip, about the new program, new focus from WorkSafe, or greater focus probably is a better word, around the carcinogens everyone risks. So I look forward to seeing more around that and how we can help. So thank you to everybody for being part of this call, and that's a plug from me as well, from Pip to the plug. Hazan's conference is 2.5 weeks away, so if you haven't registered already, get in. We're up to 380 people already, so there's only a few more spots available. So if you haven't registered, get onto that and hopefully see you there. So thanks everybody, and got 15 minutes spare in your day. So thanks for that. Have a good day. Take care.
Thanks everyone.
So the slides and the recording will be out next 24 hours. Talk to you soon. Take care. Bye. Thanks, Al.
Thanks.